Right, this is the first bit of sunshine that we've had since I've installed these, which has been about a week. This return line is warm, but this one here is hot. Right, it's about 5:30 on the first day of any real sun. It's been very intermittent sun now. I think it's probably been cloudy more than it's been sunny. Although it's sunny at the moment, but you should be able to tell from the shadow I'm casting down there. The sun's coming in this direction, it's barely touching the panels now. So they're now warm to the touch, but definitely not hot on the top pipe, and cold I'd say down there. Let's have a look inside then. Here then is the temperature of the hot water tank, and it said 27, I think it was, something like that when we started. Well, when I first checked it at 11:30 when the sun came out. It now says 33.5, more or less. When there's only a small difference between the hot and the cold, it's going to move slowly. What I discovered when the pipes on the solar panel were hot, it was hot upstairs and it was hot in the hot water tank. But here, this is the return line that I'm hoping it would use. So it comes down this return line, and then at the back here, where it would normally go into the back of this range, there's a T, and coming off of that is a 22mm. It goes down, and then we go along the floor and out to the panels. An interesting thing was that the return was actually coming down both of these, because obviously they're connected. So it's coming down both. The heat was coming down both of these, which means some of the heat was coming down what should be the feed line here, and then they were joining up where that T-piece is and going off to the panels. So I'm not sure that's really what I was after. What I may have to do at some point is put a bit of a restrictor in somewhere, not quite like a one-way valve. I think a one-way valve would be too much, it would block the flow. But if I put a bit of a restrictor, that may help. But yeah, early days yet. We'll see. What I really want is for some proper heat coming off of those solar panels, and then see what happens. Because I think once there is a big difference between the properly hot water, it's going to be much less dense than the cool water in the return lines, and we'll have a faster flow, and then it might go down the return line as I intended it to, and everything might sort itself out. But we'll see. The first thing to happen is we need some proper sunlight, consistent sunlight. The other thing I've noticed is that every time the sun came out from behind a cloud, I couldn't resist rushing outside and putting my hand on the solar panel. That's a holdover from the solar electric, because obviously as soon as the light hits the solar electric, it's making electric. But as soon as the light hits the solar hot water, nothing happens. It takes the lag is huge, so it has to warm up all that radiator, that hot box, get that heat into the pipes, and then the pipes move. So if the sun's only out for a couple of minutes, then obviously nothing happens overall. Well, it's looking like today might be the day we actually get some proper unbroken sunshine. It's just gone 9 in the morning. It's a bit hazy, there's a few clouds about. That's warm to the touch on the top line. Unfortunately, I was running the wood burning range last night, so the temperature in the water tank is about 48 degrees at the moment. So it's not a very low starting point. But still, if we get some sunlight, we'll see what happens. So it's currently about 11:30. That says 34. And the pipe there. Yeah, 34 as well. So slightly disappointing really, that not a lot's happening, but it's not the fault of the thermosiphon, or lack of. It's the panels themselves are not getting all that hot. So obviously if that's 37 degrees there, if it's 48 degrees in the tank, there's not going to be any cycle. There's not going to, yeah. There's nothing to increase that there. So the range is off, the radiators are off, so those two loops are out of the equation. The pump is off that would feed the underfloor heating, so that's out of the equation. So it should just be this and the heat exchanger. Whilst we're waiting to see then if that's going to warm up and do anything interesting, I just thought I'd mention briefly why these are so unfashionable now. They're partly unfashionable because they've been superseded by the evacuated tube solar collectors, which are inherently more efficient. But I think they've mainly been superseded by the fact that solar panels like these ones up here, the electric panels, have become so cheap that really if I owned a house and I wanted to have solar of any sort, I would just cover the roof in solar electric panels and I would use the excess power to run an immersion heater. The huge advantage of that is that there's no plumbing. If you've got a hot water tank, it's going to have an immersion heater. It's a no-brainer really. It was only a few years ago though that it was a completely different story. When I can't remember when I bought them now, but it must have been about 5 years ago I got my first set of proper solar panels. Prior to that I'd had sort of small ones that I could experiment with, but they were rubbish really. The first set I got, those panels I just showed you, which are now in the workshop, used to live here on the front of the building, and I had them hinged so that I could move them out in the summer when the angle of the sun is high and I could push them in close in the winter. I remember those cost me £500 for that set, and that's 4 80-watt panels, and they weren't very good panels either. They were definitely B-grade panels at best, but I was really chuffed with that price. I thought that was brilliant, and it was at the time. A bit later I got the panel in the middle there for £100, which seemed incredible to me, and then 1 year later I got the other 4 brand new for £100 each. So that middle one, £100 second hand, the other 4 were new at £100 just a year later. So that shows you the price crash that we had in good, decent quality solar panels. Incidentally, it's not usually a good idea to mix and match panels of different origins, but in this case the output voltages were pretty much the same, so that's fine. But for instance, I couldn't run these big panels and those small panels together because the voltages are different, so it just doesn't work properly. So they're separate arrays with separate controllers. That's the way to do it. This solar PV now is so cheap that really if I didn't already have the solar thermal panels to play with, I'd just buy more solar PV and run the immersion heater. So my setup does include an immersion heater. There's one that came with the tank, but immersion heaters run at 3000 watts, which is too much for my small array here to cope with. The way I do it, the way I get around that, is to use a 110 site transformer, and when you run the 3000 watt element inside the tank at 110 voltage instead of 240 volts, it draws about 700 watts instead of 3000, which is more acceptable as a dump load for this lot. So what happens here on a nice sunny day is the batteries get close to full, say 11 o'clock in the morning, and then I'll put the immersion heater on, and that adds 3 degrees an hour to the tank. In practical terms, what that means is it keeps the tank hot. So if I got the tank hot using the wood burning range, I can then keep it hot day after day as long as it's sunny using the immersion heater. What I'm thinking with these panels, even if they don't work very well, if I can go from keeping the hot water hot to increasing the heat in the hot water tank, then I don't need to light the range. So that would save me lighting the range all summer, so that would be a big bonus. Of course, the other things that I'm trying to do with this system, if it works, is pump heat into the floor and things like that. That's all. Yeah, possibly trying to get too much out of it, but it's fun to try. Okay, it's after lunch. It's sometime after 1 o'clock, about 20 past 1, and the sun's about at its highest, 43 degrees here as it leaves this panel. As that hot water gets hot, it becomes less dense and then rises up through the system. It's not rising by itself, it's being pushed up by the colder water coming down in the return loop. The return loop it comes down is 28 mil for the large drop of it, because it's sharing the same drop that the same part of the loop that the wood burning range does. So that's coming down, that's to encourage that cycle. So it's the cold water drop that's just as important as the hot water rise when you're trying to develop a thermosiphon system. So it is working, the thermosiphon system is working, but the heat output is unimpressive, let's say. It's warm rather than hot. So I'm aware that these things don't work well on metallic surfaces, but here where it's highly oxidized, I should get some reasonable reading. So there, 43 on the return line. Yeah, about 30 there on the return. That feels about right. Yeah. So in a bid to make this thing more accurate, I'm going to put a bit of electrical tape on here and then take the reading from the taped area. It's now 3:20 in the afternoon. There's not a cloud in the sky. So I think it's 41 off of that one. Yeah, and I'll expect the hot water tank to be the same, so I'll just go and check that. So the hot water tank is at 45 degrees. So I think all I've achieved today is to keep the hot water tank hot, if you can call 45 degrees hot. I suppose it's right. Second day in a row of sunshine. This feels very novel. What we got? It's clearer today. There's a very slight haze over there. The rest of the sky is completely clear. It's about 10 o'clock in the morning now. The hot water tank had a lower starting temperature today than it did yesterday. It's about 36 degrees at the moment. 37 on here at the moment. And we've got 23 on the return. So if today's anything like yesterday, what I'm expecting is for the heat in these panels to get up to the mid-40s, but this time it'll push up the temperature in the hot water tank to match that. I'm not worrying about the underfloor heating today, or the radiator circuit or anything like that. I've just got the solar panels running up, so that water will be running up through the heat exchanger. It's coming back down behind the boiler and along the floor and back to this. That's it. Right, it's about 12. 46, 47 degrees on there. Still not wildly exciting. I'm getting about 40 off the pipe, but that is, like we found out earlier, quite insulated, the pipe. So far, the performance then in sunshine, bearing in mind it is April, it's, you know, it will get hotter. Although having said that, the ambient temperature is around about 20 or so in the shade. So it's quite a warm day by English standards. Yeah, so at the moment the performance I'd say is about on a par with the immersion heater. Bearing in mind the immersion heater is throttled down to run at 700 watts instead of 3000. So the 700 watt immersion heater is about the same as what I'm getting from these panels at the moment. But obviously I'm not using it today because I'm testing these out. Between the two I would get a nice full hot water tank, but yeah, I was hoping for more from these really. I'm surprised the temperature leaving isn't higher. It's just gone 2 o'clock in the afternoon. Just checked the temperature of the hot water tank inside and it's about 40 degrees. And that seems to be what I'm reading here. Once I block the sun for a bit, so that I'm not reading the pipes are obviously warming up in the sun by themselves. So if I block the sun out, then I'm getting a reading of the water that's coming through them, and that seems to be in the 40s. So that seems to be about right. Now I don't know if it's just that the panels are not producing that much heat, or whether they're being continually cooled by the cool water that's coming in on the return line. So it may be that they have more to give when that return line is coming in at a higher temperature. But of course by then, if there's a similarity, that will slow the flow. Right, it's about 4:30. These pipes are noticeably cooler to the touch. So yeah, about 34 degrees we're reading now. They're pointing pretty much due south, but as soon as the sun is past about 3 o'clock, a very noticeable plummet in the performance from these. The idea of this system then is it should just work by itself without any input from me or minimal input, just switching the loops, I suppose, if I wanted to shut this off if I'm going to like the range, shut off the radiators if I'm going to use this. That's about all the input I want to do to it. So no controller, no microprocessor controller or anything like that. It's just a purely analog system that I can just leave to get on with things. Right, it's day 3. I haven't bothered measuring as much today because the sun, well, there wasn't really any sun at all until lunchtime. We started today very, very misty, and then this afternoon it's been sunny but with a real haze on it. The sun's been nowhere near as intense as it has been for the previous 2 days. So we're currently reading about 35 degrees. I think what's been shown so far then is that when the sun comes out and it hits that panel and the panels warm up, they quite happily bring the tank up to whatever temperature the water is leaving the panels. It's obviously not going to get any hotter than that in the tank, and there is some loss on the way as well, so it's going to be a couple of degrees below what these can manage, because I haven't insulated the pipe where it goes into the sleeping loft yet. I will do, but I haven't done it yet. So there's a bit of optimizing to do. But what's holding the system back at the moment is that lack of temperature as it leaves the panels, which is, again, I say that does surprise me a bit that it's been that low. Now, if I pulled the panels out a little bit, that would improve it. But really, for spring and autumn, which is what I was trying to optimize the system for, mounting them vertical against the wall isn't actually a daft idea. And the intense summer sun, I think these will be belting along. The other thing I've discovered about these kind of solar collectors is that they have quite a limited, what would you call it, angle of incidence, I suppose. So by that I mean that the sun has to hit them almost full on for them to be working optimally. So it's quite a while after the sun comes up that starts to happen, and it's now about 20 past 4 in the afternoon, and already they're cooling down. In contrast, I have here one of the tubes from the other system that I've got. This is an evacuated tube solar collector. So these, you put a group of these. I've got not quite a full set, so I've got 13 out of 14 tubes, and the system that I've got, you would put in groups, 2 groups of 7, and they would lie on your roof like that. This consists just like this one in a sense. It's got a copper sheet and a copper pipe, but there the similarity ends, quite obviously. You might be wondering why I haven't fitted these, since they are more efficient. I probably will at some point, but it is more, one, it's more complicated to fit these. 2, they do need a pump, and 3, I don't have all the stuff, so I'd have to get some in. Anyway, the point I'm trying to make at the moment is that this, if you think about it, the nature of this tube means that the sun can be effective from lots of different angles, whereas the panel behind it, not so much. Whereas this, just in this curved bit here, it can come in all over the shop. That's one of the advantages of these tubes. The other advantage is that each tube can heat up on its own. So rather than the whole panel having to get up to temperature, like on these ones, each tube, being a self-contained unit if you like, can get up to temperature faster, and it can shift water quicker. There's much less volume of water being moved about, but it happens faster. So on overcast days, well, not overcast obviously, but on days of intermittent sunshine, let's say, you're likely to get more out of a tube than you are out of a flat solar panel. But once again, I want to emphasize the fact that overall efficiency is not terribly important right here. If I was buying these new, if I was buying any kind of solar system new, obviously efficiency would be a really big consideration, because I'd be thinking about the payback on the money that I spent out. But the fact these didn't cost me anything and these didn't cost me anything means this is just an experiment to see what can happen. So what I've discovered so far then is that this on a spring day will produce warm water. Now if I want hot water in my tank, on a day like this I can run this and the immersion heater, which remember is running at 700 watts, and then by the end of the day I would have a tank of hot, and that's great. After that first day, if it's sunny after that, these would maintain it at, let's say, 40 something degrees. That seems to be about it for the spring, and I'm going to assume that's a similar story in the autumn. When we get round to summer, the sun will be more intense. I'm expecting a higher temperature from this. Endless hot water then? No, not really. Not thus far anyway. But on a day like this, when it's sunny, even if it's only been sunny for half the day, I could expect a great deal of warm water. Now that can be useful. Warm water coming out of here at 40 degrees is very similar to the heat that is allowable to be pumped into the floor. Remember, you can't put too hot of water straight into the underfloor heating because the concrete will crack. So the floor wants heat at about 40-45, and that's going to be what's coming out of these panels. So I could run that pump and pump it into the floor. I haven't tried that yet because I've been trying to work out the thermosiphon system. Now I know the thermosiphon system works. I also know that the underfloor heating works, so I know without testing that that's an option. So my idea of a spring or autumn day where it's sunny but cold at night, this system will work for that. It seems that I can take all the output from this and pump it into the floor. What I'm trying to say here is that the thermosiphon system is only going to work when this water leaving here is higher than it is in the tank. So as soon as the tank gets up to the same temperature as these panels, that system stops effectively. Even if I pumped it, it wouldn't get any hotter in the tank because this is as hot as the tank. Obviously in summer I think that will change. But that water leaving there at 40 odd degrees can be useful. If I was to pump that into the floor, it would keep coming at 40 degrees from these panels, so I can make that other loop work. So where it goes up here and up into the sleeping loft, I can pull that down into the floor and send it back on the same return line. So instead of it thermosiphoning all the way through the heat exchanger, it's going about half the distance, but into the floor, back out the floor, and then here. And I think that energy, that temperature of water at 40 degrees, it would be able to sustain that all day long. What I need to do is to set the pump speed so that it's not going too fast or too slow, so that the panels have plenty of time to replenish that heat before it's taken back around the floor again. Does any of that make sense? Thanks to a couple of the commenters on part 1, I started looking into polycarbonate sheeting, which you can use for greenhouses, and it does come in the bigger sizes as well. So I'll be able to replace this glass with polycarbonate at some point. It's like 4 mil thick, which is the same as this, so it will just go straight in there. This plastic pipe is polybutylene pipe. It's rated for a continuous 95 degrees and for a peak of 115 degrees. So I consider it safe to be in this system. So it's fine. It's not just a bit of ABS pipe that I pulled out of the workshop and pressed in the service. It is rated for hot water. So yeah. And according to the manufacturers, it's completely fine to use compression fittings with it as well. If this system ever did start to get properly hot, I would open the radiator loop, and then I've got all that volume of water that's in those 3 massive radiators would be able to come in through the bottom of this and through this cycle, cooling it down. So I can't really picture a scenario in which this does get to boiling temperature in here, but yeah. If it does, obviously, I'd have to replace this or redesign the system, but for the time being I think what I've installed is inherently safe. Does it work? Yes. Can it be improved? Yes again. Does the thermosiphon system work? Yes it does. Would I recommend it? Well, maybe. Personally though, if I was building the system from scratch, or if I was building another house, I'd just put loads of those panels up. If I had double the amount of solar electric, I wouldn't even think about this for hot water. Having said that, no matter how much solar electric you have, you're not going to use that excess power to put into the underfloor heating. It's not going to produce that much. It'll produce enough to heat up a tank of hot, but the fact that this can produce warm water all day long, that can be utilised in the floor, and solar electric I don't think would allow you to do that. There's just not going to be enough excess on there. It's not really a recommendation, is it? It's a recommendation with an awful lot of caveats. There are situations in which this will work, and I think for my situation, these two panels are going to be a massive boon throughout the summer. So from about, I'm hoping from April where we are now through to September, maybe even a little bit more, these are going to do a lot of work. So it was worth doing. I'm going to carry on testing these. I'm going to carry on optimizing it. I'm going to carry on tinkering with the whole system all throughout the summer. But rather than make you wait that long for this video, I'm going to put this out now, give you like a preliminary results, and then if there's enough interest I'll make an update at the end of the year perhaps, something like that. But for now, as ever, thanks for watching. I'll see you on the next one. Cheers.